which means you may have to measure the concentration of sodium hydroxide. In this case, we just know ahead of time that the concentration of sodium hydroxide is 0.502 molar. Now, obviously, if we know the concentration and we know what volume of sodium hydroxide we add, then we know the number of moles of sodium hydroxide we've added. So the first thing I would suggest is that when you come into the lab, it's a good idea, set up your burette and then pour a little bit of sodium hydroxide into the burette to rinse it out. Okay, you don't know what other people have been using this burette, where it's been. Okay, so add a little bit, wash down the sides, and when I say a little bit, I mean a few milliliters, and then drain out that sodium hydroxide. And if it doesn't drain out, what you can do is add a little more, and there we go. Okay, so we're going to just let all of that run out, and we're just going to discard that. That's nothing. We're not going to keep that at all. So we'll do that. Okay. Now you'll see that an air bubble develops right here when we let it all drain out. And we're going to have to get rid of that air bubble before we start. Let's now fill up the burette for real. And what we do is we add the sodium hydroxide. You don't have to get it all the way up to the 0 mark. In other words, you don't have to get it all the way up to the top, but you do want to get it close. And all you need to do is be able to measure it exactly. So it doesn't have to be on 0. You just have to be able to read the burette. And I'll explain that in a moment. All right, so we're at something close to 0. It's up at 3 right now, about approximately. Okay, so it doesn't have to be all the way up to 0, but what you want to do is you want to read off what the value is. First, let's get rid of this bubble. And the way you do it is open up the stopcock and let it run really fast, and it'll typically push that bubble right out. And we want to make sure there's nothing stuck on the tip. Okay? And then let's read where we are. To read it, it's a good idea to get a white card with a black piece of electrical tape, or maybe just some black ink. Hold it behind the meniscus, and it helps you to read the burette. I'm going to turn this towards me a little bit more. And it is at 3.75. Let's call it 7.6. Okay, 3.76. Now, notice that I read that to 3 significant figures, and the reason why you can do that is that the burette is graduated. The numbers indicate milliliters, and then there are other tick marks for tenths of milliliters, and you should be able to extrapolate between any 2 tick marks to get something reasonably close. And what did I say? 3.76. What did I say? 3.7. Let's call it 373. So 3.73 milliliters. Okay, that's where we're going to start. And now let's begin our titration. What I did was I took a pipette, a volumetric pipette, and I pipetted out 20 milliliters of vinegar. So that's in here. And now we're going to begin our titration. It's a good idea also, since we're looking for a color change, to take a piece of white paper and put it underneath your Erlenmeyer flask. Erlenmeyer flasks are good for doing titrations rather than beakers, so it's better not to use a beaker, better to use an Erlenmeyer flask, and the reason is we'll need to swirl it, and swirling something that's shaped like this is better to make sure that you keep everything in. Now, the equivalence point is when we've added exactly the same number of moles of sodium hydroxide as we originally had moles of acetic acid. And you can't see that, right? It just happens. But what we're going to do is we're going to add something that changes color roughly in the pH region where the endpoint occurs. And that compound for titrating weak acids with strong bases is phenolphthalein, and we're going to add just a few drops of phenolphthalein to this solution. Okay. And remember, we're only concerned with the number of moles of acetic acid in here, so we can always rinse down the inside slides of our flask. So we'll do that with distilled water. And now what we're going to do is start our titration. Now you can run it fast at the beginning, and I know roughly the number of milliliters of base that I have to add to get to the endpoint with this titration because I did it before on camera, and it's a good idea, since you almost always do titrations multiple times, to go ahead and do the first one sort of fast and then not worry about what that data is, and then it'll save you the time, because when you come back and do it again, you can do it more quickly. So in other words, I know that it's going to take roughly 35 milliliters to get to the endpoint of this titration, so I can go ahead and add close to that volume without even worrying about overshooting the endpoint. Okay, so I have now added The volume here is 29, so I've added 26 milliliters, so we have a ways to go yet. Let's go to 30. And you see that I'm swirling and rinsing down anything that might be clinging to the sides of the flask. If it splashes, okay, now when the pink color starts to linger for a while, you know you're getting close. And what we're looking for at the end point is just the palest, barely perceptible pink. And if I get this right, you'll be able to see what we're talking about. So what I'm doing now is just adding little bits of base. And swirling in between to make sure that that color is going to go away. And then when you get really close, one technique you can use is to just sort of take your the stopcock and sort of give it a quick flip. And when you give it a quick flip, you introduce a really tiny amount of base to the reaction. I can see that there's something stuck on the sides here, so let me rinse that down. Good. So we're going to sneak up on it here. We should be getting really close. You can see that the pink color is starting to last a little bit longer. And we swirl.